I'm Shravan Kumar from Delsoft Technologies, New Delhi. Today is our second day for this faculty development program, which is on network simulation using Netsim software. So today we will have first the introduction of the presentation, then we will have hands-on on Netsim software using MANET scenario. So, so why we use Netsim or any other simulator? So as you know, with the advancement of technologies, newer protocols are being drafted very frequently, and it is very difficult to keep updated with the latest happenings and analyzing network behavior using traditional analytic methods. So it is not easy to manually analyze those network behavior, considering the fact the large number of parameters are involved. So we use these network simulators which are used to provide an accurate understanding of network behavior and their associated problems and solutions. Now, Netsim customer segments. Netsim introduction. So Netsim is a scientific tool which is used for designing and validating networks and their protocols. Hence, it has a lot of relevance in protocol research and development. And in defense, for instance, it is used for simulating network-centric warfares. It has a wide range of technologies uh, possible to simulate in Netsim are internetworks, which is having LAN, WAN, wireless LAN, mobile ad hoc network, that is MANET, then WiMAX, cellular network, which consists of GSM and CDMA, cognitive radio network, LTE network, and wireless sensor network, which includes ZigBee and IoT, Internet of Things. And Netsim is having two versions. One is academic version and a standard version. So in academic version, we can design and analyze the network using GUI, but in standard version, users are provided with C source code of network protocols which are implemented based on the IEEE and ITF standards. So the purpose of this is to enable users to edit the protocol code according to their own requirement and link it with Netsim and analyze the performance of newly designed protocol. Now Netsim has some customer segments right from enterprises, defense, R&D labs, Hello. In academics, it is used for network labs, network labs, and PhD thesis. In BTech, we have some network labs, computer networking lab. In MTech, we have advanced network lab. Then it is used for a PhD thesis. Now, this is the architecture of Netsim, which provide you a holistic view of Netsim. Users will design the network and configure it in GUI, which will be further simulated by Netsim engine and thereby provide multiple metrics regarding the performance of simulated network. So here you can see in the screenshot, it can be started through CLI and GUI, and when the network is designed using GUI, it will create an XML configuration file, which is further simulated through virtual network stack. And after the simulation, metrics will be generated. Then some traces like event trace and packet trace. Okay. Yeah. Sir, attendees are some different attendees are there, so we are just giving an overview of the software. After that, we will have the managed presentation using the software. So that's why we are just giving an overview for all the attendees. We are just giving a quick review of the software. Okay, so this software is divided into some components. So first is component 1, which is used for inter-networks, wired and wireless network, and these are all designed as per the international standards. Then some common module applications are there, where you can generate various kind of traffic on voice, video, FTP, database, HTTP, email, various kind of traffic you can generate. Okay. Then component 2 is legacy network, that is having Aloha, CSMA/CD, token link, token bus. Then in component 3 it is BGP. Component 4 it is advanced wireless network, that is MANET and WiMAX. And the MANET is having DSR, AODV, OLSR and ZRP protocol. Okay. And component 5 is having cellular network, that is GSM and CDMA. Then in component 6, wireless sensor network is there, and personal area network, and newly added IoT, Internet of Things. Then in component 7, cognitive radio network, it is wireless radio area network. And in component 8, it is LTE, long term evolution. And in component 9, it is military radio network. So this is just a brief about the components. And this is the what's new in version 9, that is which is available in the version 9 latest version, that is having some new technologies like IoT, Internet of Things, 802.11, that is having gigabit Wi-Fi. Then military radios having HF and UHF bands. Then network emulator add-on module has been added, where you can connect the Netsim to real-time devices. Then interfacing with some software like MATLAB and Wireshark, and some multi-threaded kernel has been added just to increase the performance of the software. Now it's hands-on is divided into two parts. One is model, simulate and analyze, and then write your own code and link it with Netsim. So we just go to the part 1 where we can design the network, configure the network by setting the parameters, and model traffic where we can generate various traffic on any node and simulate the network. Then this is a summary of this modeling and simulation where you can see some screenshot is given there, and application type is there where you can generate various kind of traffic, voice, video, FTP, etc. This is two ways of running the Netsim. One is through command line interface, or other through XML based config files. So we usually prefer XML based config files which are very better for better presentation and quicker understanding. Okay. So now after the simulation we will do the analysis where performance matrix is given. Then packet animator is there. Packet animator is there for seeing the packet animation. Then packet animator, it is for seeing the animation where data packets move from one node to other. These are the matrices given. Matrices created after the simulation. There is network matrix, application matrix, link matrix, protocol matrix, and device matrix. So as the name suggests, they will give the information about the network, application used in network, and link used in network, in protocols and devices. And this is a screenshot of the packet animation where packets move from one node to other. You can increase or decrease the size of the animation. Now these are the some of analysis which is used in standard version only, like traces, that is packet trace and event trace. Packet trace will give you the information about each and every packet that is generated after the simulation, and the event trace will give you the information about the events performed in the network. These all I'll show you in the network simulation after the presentation. Then dynamic matrix is there where you can create some graphs of links and application throughput that can be plotted offline or during the simulation. This is Wireshark. Wireshark is a open source tool for capturing the real-time packets. Where you can see in the screenshot, some TCP packets have been captured, and these are some graphs that is available in the Wireshark only. Now in develop platform, there are two screenshots available where you can write your code in the Visual Studio and you can link it with Netsim in the GUI. And these codes are available in the installation directory. And these are some APIs that is available for protocol developers. It's packet.h, stack.h, list.h. These are some APIs given for the protocol developers, which helps in the development of some protocols. And these are some customer base for Netsim in defense, space industries, and education international and India. Now I will go to the software part where we will design a managed scenario and see its output. So for designing any network, you have to go for new internetworks. In internetworks, you can design wired and wireless network, and in legacy networks, these are available: pure slotted, traditional Ethernet, advanced wireless. It is MANET and WiMAX. Then BGP network, cellular network, it is GSM and CDMA. Wireless sensor network, then IoT, Internet of Things, then Zigbee network, cognitive radio network, and LT network. So if you want to design advanced wireless network, MANET, you have to select from there. Now we are into the scenario environment of the software. Here we can see nodes are available, because in MANET we only use wireless node. So all nodes are disabled. So we just have to drop down some wireless node here. Here in this particular experiment, we will increase the size of increase the speed of this wireless node, and after increasing the speed, how it will affect the throughput, we will see in the result. So we have to set some parameters from here. So right click on properties, and we have to set, we can set the position just to align them in one row. This 250, 100, and we can change their mobility model to random walk. First we will have 10 meter per second, then accept. Then for node 2, we will change the position 200 and 150. Then again mobility model to random walk, accept. (300 to 150) and mobility model to random walk at 10 meter per second. Then for node 4, it is 250, 200. Then mobility model to random walk. Then node 5, 225 to 125. Then mobility to random walk. Then in node 6, we can change it to 275 and 175. Then mobility model to random walk. Okay, we'll accept. We're just given this parameter to align them in one position. For seeing the different parameter, we can go to the interface wireless, where IP addresses of every node is given there, and each and every layer, that is network layer, data link layer, and physical layer. Okay, and their power, either it is mainline or battery power, and the standard channels available. Okay, then frequency bands, bandwidth, transmission power, their standard. The data link layer, you can change this rate aggregation algorithm and the retry limit. So different parameters are given according to the wireless nodes. So you can these are set at the default values. You can also change it or accept it for default. In network layer, we can see routing protocols, that is having DSR, AODV, ZRP, and OLSR. Okay, so we just select the DSR only just for now, and this acknowledgement type, that is link layer or network layer. In transport layer, we will use the UDP protocol. We will disable TCP. Global properties, we just set. Okay. So now we will send some packets from one node to other. So for that, we have to drop down this application tab. Right click on properties. And we can select the application for custom, and from source ID 1 to 4, and packet size is constant. Value, we will simulate it at default values. Then we can add some more applications. Add custom, source ID 2 to 3, all values are same. Then add application 3, source ID 5 to destination ID 6. Okay, so we have added 3 applications here. We have added 3 applications. Now accept it. We can see these lines which shows the custom type of packet is will move from 1 to 4, 5 to 6, and 2 to 3. Okay. We can set the environment properties also. The channel characteristic is given there. Fading and shadowing, fading only, line of sight, no path loss. So for this instance, we will set it to no path loss, or we can change it to line of sight of path loss component of 2. Okay. Now I have told you in the presentation that various analysis can be done after the simulation. So we have to set those parameters from here only. Just select the packet trace if you want to see the packet analysis. So that file name would be packet trace, file type would be that CSV format, and these are the attributes for Manet. You can select it. Then event trace is given, where you will get event trace. These are attributes. Just click on OK. Then in dynamic metrics, you will get application matrix, link matrix, and congestion window. So you have to select the plot graph after simulation. Click on OK. Okay. So after this, we have to run the simulation for 100 seconds, and we will record the animation as you will see after the simulation. Click on OK. So after the simulation, we will get performance metrics. In performance metrics, we are having network metrics, link metrics, then application metrics, okay, power model metrics. So there are various parameters given in network metrics, that is having simulation timing, packet transmitted, packet errored, packet collided, bytes transmitted, payload transmitted, overhead transmitted. So this is overall network performance. Okay, and this is link metrics. What link has been used for sending the packets. Okay, and this is power model metrics. And what we want to see here is application metrics. Okay, in application metrics, we will get the overall throughput of the network. As we have added 3 applications from source ID 1 to 4, 2 to 3, and 5 to 6. So we can see in the throughput, we are getting 3 different throughput. So if you want to combine these throughput, we will get an overall throughput of network. So as you can see, this will combine to almost 0.46, around 0.46 this throughput. So now we will do, we will increase the mobility of the our node. So from 10 meter per second, we will increase it to 30, then 50, and we will see how our throughput will vary. Okay, so first I'll show you some other features also. Like we have added packet trace and event trace. So open packet trace. Okay, here you can use the filter here in Excel and analyze one by one packet. You can analyze the various numbers like 1, 2, 3. These are the packet numbers. You can analyze each and every packet, either it is sent successfully or not, what path it is using, what data it has been sent. So all these information you will get from the packet analysis in packet trace. Likewise, you can open event trace. And see the events, one by one events performing in the network. Okay, their event type, event time, device ID, interface, application, all this information in the event trace. Okay, and then view packet animation. We can see the animation, packets moving from 1 to 4, 2 to 3, and 5 to 6. Okay. Then increase the animation speed just to show the packets moving. So we have set the velocity to 10 meter per second. So it is moving very slow. So we will increase the speed of these devices just to see how their mobility will affect the throughput. Okay, we can stop it here. Now we can save it. And go to the scenario again and add it. And now we have to change the velocity of all the nodes. Let's say 10 to 30 we are increasing. Okay. Now we have set the velocity to 30. Now we will simulate. Okay, so result is there, performance metrics. Now we have to see only the application metrics and their throughput. Here we can see the output has decreased. If we add this throughput, it will come to around 0.3. Around 0.3. In 10 meter per second, it was 0.46, and in 30 it is 0.3. Now we will increase it to 50 and see how it will affect. Just save it. Okay. Again we go to the scenario and add it. Now velocity would be 50. Okay, we have set the velocity to 50. Now we run the simulation. In application metrics, if we go at 50 meter per second, it will come at 0.18, something 0.18. So we can see according to this analysis that as we increase the velocity between these devices, our throughput will decrease, because uh, when devices move very frequently, they will lose the data in between them, and the losses would be great. So it will decrease our throughput. We can see in the packet animation also. As the nodes move very frequently, so they will lose the data and hence decrease the throughput, overall throughput. Okay. So we can stop the animation and go for further analysis. You can save it. The attendees who are new today, I just Wireshark application, how you can use it. On any node, you can enable the Wireshark by click it to online, and when you run the simulation, the Wireshark will run during the simulation. So you can see the packets are being captured, UDP. So it is capturing packet during the simulation. Our simulation is still running. The simulation is ended now. So we can see the packets, UDP packets. Okay. So there are some features of Wireshark also in statistics. You can click on conversation. Yes, we can import it. So these are some details. If it is available, you can print it. Yeah. So you can close it for now. So these are some features of Wireshark. There is one more tool, that is Netsim Analytics. To save this also. And if you open Netsim Analytics, you can compare various metrics related to uh, your used technologies. Like we are using MANET. So this is our first matrix. Then the second. This is third. And this is fourth. So we have added 4 matrices that we have added recently. Here we can see the comparison between these matrices according to their simulation timing, packet transmitted, packet errored, packet collided, then bytes transmitted, then payload transmitted, and overhead transmitted. So you can add some more metrics, or you can delete it from here according to your requirement. This is just to show you the comparison between different experiments we have done and their differences. Okay. So till now we have seen the design and analysis of MANET using the GUI interface. Okay. So now we will see how we can edit any protocol using Visual Studio environment. So for editing any protocol, you have to go to the installation directory of Netsim. That is C program files and Netsim standard. Here we are having 3 folders. One is a bin folder. If you open it, you will have the DLL extension of different protocols, like Lip Cellular, DSR, cryptography. All these protocols are available in Netsim. So any protocol you are creating, your own protocol, or you are editing any protocol, you have to save it for DLL extension only, because Netsim understands the DLL extension. So in Netsim standard only there is SRC folder, and in simulation there is an extension of netsim.sln. If you click on this, the Visual Studio environment will open, having so if you click on DSR, you have opened the DSR protocol and added a hello world command in it. Okay. Which is under the Netsim init function. So if you build it, it will create a DLL file. For building, you just have to click on this, right click and build. So we have already made a DLL file that is in the DLL folder, libdsr.dll. So we have to copy this DLL and paste it into this bin folder. Before that, we have to rename our original DLL file so that it will not affect our original DLL. So we just rename it. to libdsr default, and now we paste our libdsr.dll here. And now if we run any program that is using the DSR protocol, so this is a managed scenario. It is using the DSR protocol and sending one serial packet from 1 to 5. So if we run it, first it will print your hello world command, then after it will go to the simulation until you press the enter. So just hello world is printed. Hello world is printed now. If we put enter, the simulation will run. Okay. So this is just to show you how we can change anything in the protocol and create our own protocol also. Apart from this simulation, we are having some programming exercises that are available here, right from ARP, address resolution protocol, cryptography, distance vector routing, PC to PC, all these you can see here. Like if we use the shortest path, and there are two ways of running it. First, there is a sample programming running behind this GUI. You can use it, or you can create your own exe file in the Visual Studio environment. We first run it through sample. Let's say we use number of routers 4 and connect it and give the distance. Okay, so we have created this scenario for 4 routers. We have to set the source router. Just use 3, and destination router is 1. And if we run it, it will show you the shortest path of sending the data according to the algorithm written in the program. So here you can see the 3 to 1 is the shortest, as it is seen from the GUI only. So it is calculating through the algorithm. So if you want to see the source code, you can click it and it will open that linkstate.c program in Visual Studio. Here you can change the programming, or if you want to create your own protocol, you can write it the code and save it for exe file. So if you use the user, you click on user, it will ask you the exe file. So if you browse that file, it will open and run it through your exe file. Okay. And this is concept, algorithm, pseudocode and flowcharts available. And manuals are available inside the software, user manual and experimenter manual. User manual is overall manual for using the software. And in experimental manual, there are set of experiments given using different technologies. Around 25 experiments are there. Okay, 25 experiments are given there. Okay. Using different technologies. This is the graph I have forgot to show you, that throughput of that mobility versus throughput graph. If you plot it, it will look like this. If you increase the speed, the throughput will decrease. If you plot it accordingly, it will look like this. Okay. So this is all about my presentation for today. If you have any query, you can write in the chat box, because if I open the audio, there will be a lot of disturbance. So you can write your own query. Sir. बता दिया मैंने, करेक्ट बता रहे अभी भी लेफ्ट दिखा रहा है। Any other queries? If you have any query, you can write us on this mail. You can call me this number.